Hey guys, my name is Hamza Arshad and today we're going to do the topic circles, under which we'll discuss equation of a circle. Alright, so first things first, the standard notation in which a circle equation is written is as follows: x minus h whole square plus y minus k whole square is equals to r square. In this equation, hk is the center of the circle. Basically, h is the x value of the center of the circle and k is the y value of the center of the circle. And r is the radius. So x minus h whole square plus y minus k whole square equals r square. So this is basically the general form of a circle equation. Now, for example, you have this circle given to you, right? And for this circle, we have the coordinates of the point C, which are 3, 4, and we have the coordinates of the point A, which are minus 1, 4. Now, A lies on the circumference of the circle, and that means that the distance AC is the radius, right? So we know the center, we know the radius. The center is 3, 4, and for the radius it will be the distance AC, and when we calculate that we'll get the distance 4 units. So referring to the general equation that we had over here, x minus h whole square, right, plus y minus k whole square equals r square. So here we have the equation of this circle as x minus 3 whole square plus y minus 4 whole square is equals to 16. So here, remember to do one thing, and that is to square the radius, because that's a mistake people usually make. Make sure that when you're writing this equation, the radius is squared. So here you have the radius as 4, so on the other side you're going to write 16. And you have the center 3, 4, so that's going to be x minus 3 whole square plus y minus 4 whole square according to the general equation. Here we have another example. Here we have this equation x minus 5 whole square plus y minus 5 whole square equals 25. So simply we know that according to the general equation, we can find the center of the circle as 5 comma 5, and the radius, remember in the equation this number 25 is basically the square of the radius, because the radius is squared in the equation, so the radius is going to be the root of 25, and this will give you 5 units. Alright, so here you have another form in which they can give you the equation. You can see here that this is clearly not in the form that you had the previous equation in. So here you have x squared plus y squared plus ax plus by plus c. So basically when you expand the brackets of the original equation form, you get a final equation that looks somewhat like this. And if you have to find the center of the circle, now there's a short form of doing this, but I will go on that, but I will like talk about that short form after what I'm about to do now. What I'm about to do now is I will write this equation that they've given us, which is basically the expanded form of the original equation, and I will write this in the form of the original circle notation equation. That's like x minus h whole square plus y minus k whole square is equals to r square. So let's see what we're gonna have to do. X square plus ax plus y square plus by is equals to minus c. All right. So now, since make we have to factorize this, right? We have to make this into x minus something whole square. So we will do this by writing this x square plus ax plus a upon 2 whole square minus a upon 2 whole square. And same for the y side, y square plus by plus b upon 2 whole square minus b upon 2 whole square is equals to minus c. So now, since this entire thing can be written as x plus a upon 2 whole square, so that's what we're going to do. And for the y side, we're going to do the same, plus y plus b upon 2 whole square. And now, since we've bracketed these parts of the equation, like these two parts of the equation, these parts are still left. So we will shift these both parts on the other side. which is the side where we have c. So a upon 2 whole square plus b upon 2 whole square minus c. Now you have something that looks like the original equation, because when you have the original equation, it looks like this: x minus h whole square plus y minus k whole square is equals to r square. So the summary of this calculation is that the center of the circle is minus a upon 2 and minus b upon 2 for the y coordinates. And for the radius, you can see here that on the right hand side you have a upon 2 whole square plus b upon 2 whole square minus c. Since this is the square of the radius, you want to find out the radius, you're going to root it. So the summary of the above calculations are that the center of the circle is minus a upon 2 and the y coordinate of the center is minus b upon 2, and the radius is root of a upon 2 square plus b upon 2 square minus c. This this summary is what you should memorize, because in the actual SAT you will not have the time to carry out this entire calculation again. So the method that I would prefer is to simply remember that the center of the circle is minus a upon 2 and minus b upon 2, and we already know what a is. A is basically the coefficient of x, b is the coefficient of y, and c is basically the constant. There's no x or y attached with c. C is just a number itself. So this is the summary of the above calculations. Now let's talk about an example. Here we have: find the center and the radius of the circle with the equation x squared plus y squared minus 6x plus 8y minus 24. So we know that for the center of the circle, we have minus a upon 2 and minus b upon 2. So a here is minus 6. So minus of minus 6 upon 2, and then minus of b, which is 8. So minus 8 upon 2. And this gives you the center of the circle as 3 comma minus 4. Similar thing for the radius: a upon 2 whole square plus b upon 2 whole square minus 20 minus c, which is 24. So this gives you root of 49, which is 7. And so now that we have the center and the radius, we know that the alternative way to write this equation is x minus 3 whole square plus y plus 4 whole square equals 49, which is the square of the radius. Alright, so this basically sums up circle equations.